All right, folks, today we are going to continue our work with polynomials, and we will be multiplying polynomials. Now, the good news is that to multiply polynomials, there are only two skills that you need to know and understand, and both of them you already do. So when you multiply polynomials, the first thing you are going to be using is the distributive property, which I know all of you are familiar with. All of you know exactly how to use that. And then the second thing that you're going to be using is the product rule. And that product rule we reviewed when we were talking about our laws of exponents. And remember that it told us that if we wanted to do a multiplication problem where we had a base of x raised to the a power times a base of x raised to the b power, that we could do that by keeping the base of x and adding the two exponents together. So that would be x to the a plus b power, which makes sense. Product rule was for multiplication problems, and multiplication is the operation that we're going to be doing. So all you need to know to multiply polynomials is your distributive property and your product rule. So let's start out nice and easy here. Let's say that I have 5x being multiplied by 2x squared minus 8x plus 4. So let's look at this multiplication problem. I have one term, 5x, so that would be a monomial, being multiplied by a trinomial in parentheses because it has 1, 2, 3 terms. So if I want to do this multiplication problem, all I have to do is distribute this 5x to every single term inside of the parentheses. And as I distribute, I use the product rule to help me do my multiplications. So I'm going to start out by doing 5x times 2x squared. Now we know we'll multiply 5 times 2, which is 10. And then we'll do x to the first times x to the second, which is x to the third. So for 5x times 2x squared, we'll get 10x to the third. Then I'll do 5x times a negative 8x. 5 times negative 8 is a negative 40. And then x to the first times x to the first is x to the second. And then finally, I'll do 5x times positive 4. 5 times positive 4 is a positive 20. And then that will only have an x on it because we had an x here, and then no x's here that are going to add on to that. So 5x times 2x squared gives me 10x to the third. 5x times negative 8x gives me a negative 40x squared. And 5x times a positive 4 gives me a positive 20x. Now, once I'm finished distributing, then I should check my answer to see if there are any like terms that I can combine. So I need to make sure that that answer is simplified as much as it can be. I have x to the third, x to the second, and x to the first. None of those are like terms, so this would be my final answer. All right, so now let's make the problem a little more complicated. All right, for this next example, we are going to do x plus 4 times x plus 3. So again here, let's take a look at this multiplication problem for a moment. We have x plus 4, which is a binomial consisting of two terms, being multiplied by x plus 3, which again is a binomial consisting of two terms. Remember, terms are connected by adding or subtracting. So what we have here is two terms being multiplied by two terms. Now, we are still going to use our distributive property. And here is the way this is going to go. And this is the way that you will do every multiplication problem. You need to make sure that every term in the first polynomial gets multiplied by the entire second polynomial. So make sure each term from the first polynomial gets distributed to this entire second polynomial. So here's what I mean by that. All right, the first term inside this first polynomial is x. So I'm going to take this x and I'm going to distribute it over here to my x plus 3. So first we'll do x times x. Using my product rule, I know that will give me x squared. Then I'm going to do x times a positive 3, which I know will give me a positive 3x. So notice that first term of x has been distributed to the entire second polynomial. Now I'm going to repeat that process with my positive 4. He also needs to be multiplied by the entire second polynomial. So we'll distribute again. So you're going to do 4 times x, which is a positive 4x, and then 4 times 3, which is a positive 12. So notice, when all is said and done, that everything in this first polynomial has now been multiplied by everything in the second polynomial. The x has been multiplied by both of these terms, and the 4 has been multiplied by both of these terms. That's what you always want to make sure you do when you are multiplying polynomials. All right, now we have 4 terms here, x squared plus 3x plus 4x plus 12. We should make sure we have simplified as much as we can. And what you'll notice here this time is we do have like terms right here in the middle. Positive 3x and positive 4x are like terms, so we're going to combine those. So my answer is going to begin with x squared. When I combine 3x plus 4x, I get 7x. And then I have my plus 12. So x squared plus 7x plus 12 is my final simplified answer. So every single multiplication problem is going to work in this way. Every term in the first polynomial is going to get multiplied by every term in the second polynomial. And then at the end, after all the multiplying is done, we see if we can combine like terms. And notice again how this is just distributive property and product rule. That's all we're using. All right, so let's try another one. Let's try this time 2x plus 5 times 3x minus 2. 2x plus 5 times 3x minus 2. So when I look at this problem, I have a binomial consisting of two terms, 2x and positive 5, being multiplied by another binomial consisting of the two terms 3x and negative 2. So I'm going to start with my first term, 2x, and I'm going to multiply that by the entire second polynomial. So first we will do 2x times 3x. Using our product rule, that will give us 6x squared. And then we will do 2x times negative 2, which will be a negative 4x. All right, now, since that first term has been multiplied by the entire second polynomial, now I repeat the process with my second term, which is a positive 5. So I'm going to do 5 times 3x, which is a positive 15x. And then I'm going to do 5 times negative 2, which is a negative 10. All right, so notice at that point, all of the multiplying is done. we've made sure every term from the first polynomial was multiplied by every term in the second polynomial. So now we're going to see if we can combine like terms and simplify. And we can right here. So we have 6x squared. Negative 4x plus 15x is a positive 11x. And then we have our minus 10. So 6x squared plus 11x minus 10 is your final answer. All right, now, for our next problem, let's do 5x minus 2 times 5x plus 2. Now you'll notice here again, this is a binomial times a binomial. Two terms multiplied by two terms. So we're going to approach this the same way we have on all of the others. We're going to start with our first term in that first polynomial, and we're going to multiply it by everything over here in the second one. So using our product rule, we'll do 5x times 5x, which is 25x squared. We'll do 5x times positive 2, which is a positive 10x. And then we'll go back and we'll get our second term, which is a negative 2 this time, and multiply it by the entire second polynomial. So negative 2 times 5x is a negative 10x, and negative 2 times 2 is a negative 4. Now, once all of that multiplying is done, check for like terms, which we have right here in the middle. This time, notice what happens though. Your positive 10x and your negative 10x are going to cancel each other out. So your final answer on this one is going to be 25x squared minus 4. So to do the multiplication, we distribute every term from the first polynomial to every term in the second polynomial, and then at the end we combine our like terms to make the answer as simple as we can. So always that's how it's going to work. Now, let me show you a problem that is going to look a little bit different. Let's say that I have 3x minus 2 in parentheses squared. Now, at first glance, you are going to be tempted on this to use your power to a power rule that we talked about when we did our laws of exponents, but you can't do that. To use power to a power, there can only be one term inside of the parentheses. And in this case, we don't have just one term inside the parentheses, we have two. So power to a power is off limits on this problem because you're trying to raise two terms to the second power. So here's what we're going to do instead. You're going to remember that an exponent is repeated multiplication. So this exponent of 2 is telling me that I'm going to repeat something 2 times in a multiplication problem. Now the question is, what am I going to repeat? Well, 3x minus 2 is what I'm raising to the second power. So when I look at this problem, what it's telling me is that 3x minus 2 will be repeated twice in my multiplication problem. So this is really 3x minus 2 times 3x minus 2. And once it's written that way, then we can see that it's just like these other problems that we've done. So we'll begin with term number 1, which is 3x, and we'll distribute it over here. So using our product rule, 3x times 3x, we know is going to be 9x squared. And then 3x times negative 2 is going to be negative 6x. Then we will move on to the second term, which is negative 2, and distribute him over here. So we'll do negative 2 times 3x, which is a negative 6x, and then negative 2 times negative 2 plus 4. All right, Once all of the distributing is done, let's look for like terms. Those should be right here in the middle. Notice this time, though, they don't cancel each other out because they're both negative. So my answer is going to start off with 9x squared. Negative 6x minus 6x is going to become a negative 12x. And then I have my plus 4. So right there is my final answer. Now, let me just say real quickly, it's important that you are really comfortable with this multiplication process, because eventually we are going to learn how to undo multiplication. So we're going to learn how to do something called factoring. And when you factor, what you would do is start out with 9x squared minus 12x plus 4. So you would start out with this answer, and then you would reverse the multiplication process to go back to this. So kind of keep that in mind as you're doing this, that we need to make sure that you're really comfortable and confident with multiplying, because eventually we are going to have to reverse this. All right, so all of these problems have worked the same way. So all I want to do here now is show you that they can't really make this more complicated. All they can do is make the problems have more stuff in them. So just for example, I may have something like 3x squared minus 2x plus 5. And I may want to multiply that times 2x squared plus 3x minus 6. So notice, still a multiplication problem just like all of these other examples we've done, but there are more terms. Your first polynomial has 3 terms, 3x squared, negative 2x, and positive 5. And your second polynomial has 3 terms, 2x squared, plus 3x, and negative 6. Now, that's not going to change how I'm going to do this problem at all. The only thing it does is it causes me to have to do a little more work. So I'm going to start here with my first term of 3x squared and make sure that it gets distributed to the entire second polynomial. So I will do 3x squared times 2x squared. My product rule tells me that that will be 6x to the 4th power. And then I'll do 3x squared times positive 3x. Again, my product rule, that tells me that that will be a positive 9x to the 3rd power. And then finally, I'll do 3x squared times negative 6. That will give me a negative 18x squared. So term number 1 has been multiplied by all 3 terms in that second polynomial. So now I'll move to the second term and repeat that process. So I will come over here to negative 2x, and I'll multiply it by all 3 of these terms. Distribute again. So first, negative 2x times 2x squared. Product rule tells me that that will be a negative 4x to the 3rd. Then negative 2x times positive 3x. Product rule says that will be a negative 6x squared. And then I'll finish this one off with negative 2x times negative 6. That's going to be a positive 12x. So now term number 2 has been multiplied by all 3 terms of that second polynomial. And now I'll have to go through this process one more time using my positive 5. So I'll do a positive 5 times 2x squared, which is a positive 10x squared. I'll do a positive 5 times a positive 3x, which will be a positive 15x. And I'll do a positive 5 times a negative 6, which is a negative 30. So notice, I go through this first set of parentheses and I take each term, one at a time, and distribute that term to the entire second polynomial. And I keep doing that until I've distributed all of them. And now, as usual, we would look for like terms. So let's see what we've got here. We have 6x to the 4th power. Let's see if anybody else is like him. All right, I don't see another term that has x to the 4th power. So 6x to the 4th power is going to be the first term in my answer. And I'm going to mark him out so we know we've dealt with him. All right, now we have a positive 9x cubed. Negative 4x cubed is like him. But then I don't see anybody else. So we'll do 9 minus 4, which will be positive 5x to the 3rd. And I want you to notice here, as I'm combining these like terms, I am not messing with the exponents. I'm not multiplying anymore. So I shouldn't be using that product rule anymore. I am just combining like terms. So these exponents and variables are going to stay the same. All right, now we've got a negative 18x squared, negative 6x squared, and positive 10x squared are all like terms with him. So if we do negative 18 minus 6, that gives us a negative 24. And then a negative 24 plus 10 is a negative 14. So we're going to get minus 14x squared from combining those. And then we have a positive 12x and a positive 15x. That's going to be 12 plus 15, positive 27x. And then notice out here on the end, the only thing left is that negative 30. So we put minus 30 on the end of our answer. And that is the final result. So I show you that problem because I want you to understand that as long as we understand that we are just distributing and using our product rule and combining like terms, that all of these problems boil down to the same thing. Some of them just require a little more distributing and a little more combining like terms than others. Now, like I said, this is one of those skills that is a really big deal. We need to make sure that you understand how to do this. So if there are any questions or you have any trouble at all with today's lesson, please be sure and let me know. Don't forget that the 9 weeks ends on Monday, so all makeup work for this first 9 weeks is due on Saturday. Ideally, I would like to have that in by at least 11 o'clock Saturday night. That will give me Sunday to get papers graded and to get grades finalized so that I have those ready to turn in on Monday afternoon. Let me know if you have any questions.